So this is section 3.5b. We're going to find the volume of cylinders and cones in this section. So the volume of a circular cylinder is equal to the product of its base and its height. So volume equals pi r squared times h, because of the base is a circle. The volume of a circular cone is 1/3. The product of its base and height. So the volume of a cone equals 1/3 pi r squared times h. Examples. Find the volumes of a right cylinder and a right circular cone. Here are the examples we have. We have a cylinder with a diameter of 10 feet and a height of 12 feet. So I'm going to write my formula. Volume equals pi little r squared times h. So it's going to equal pi times half of the diameter is 5 squared times the height is 12. So that's going to equal to 300 pi feet cubed. Volume of a cone. We've got a cone. The slant height is 10 on the cone. The radius is 6. We need to find the volume. What do I need to do first, Shatis?
Find the height, which is pretty easy because it's a Pythagorean multiple of 3, 4, 5.
Right. So what would it be?
It would be 8.
Yeah, it's 8. Because we've got 10 squared equals 6 squared plus b squared. So b equals 8. Pythagorean triple. So then we do volume equals 1/3 pi r squared times h. So that's going to be 1/3 pi 6 squared times 8, which is equal to 96 pi centimeters cubed. Questions? Yes? You can leave it with the pi, unless it says to round to the nearest decimal. Volume of a sphere. The volume of a sphere is 4/3 pi times the cube of its radius. So the volume of a sphere is 4/3 pi r cubed. Now, we can prove why it's 4/3 pi r cubed. If I take, and you need to be able to be familiar with this process. There's a question similar to it on either the quiz or test. So you need to understand what's going on here. If I took a cylinder with radius r, and the height is 2r. So that means I could fit a sphere in that cylinder with radius r. Here's our sphere. It has radius r. If I put that sphere inside this cylinder, it would touch each side. It touched the top in the one point, it touched the bottom in another point, and then the equator or great circle would go all the way around the center of that cylinder. So that sphere fits exactly into that cylinder as snug as it can be. And so if I measured the water in that cylinder, let's go ahead and do that. Let me get So I've got that situation. This sphere would fit exactly in this cylinder, touch the bottom and the top, and then along the middle. So let me get somebody. I need a volunteer. Okay, Steve. Measure the height of this cylinder in millimeters. The zeros up here, you got to start here.
It is 54 millimeters.
54? All right. Go fill this up. Water up to the top. The drinking fountain out there. So fill it up, pour it into here. Now measure the height of the water in the cylinder.
It's about 36.
36? Alright, so this is the height of that is 36. Okay, you can pour this out now.
Back into a drink fountain.
That's fine. Alright. So, we'll wait for Satish to come back. Thank you. So, if I take the height of the water and put it over the overall height of the cylinder, what fraction do I get? What is that? Nina?
2/3.
Yeah, it's 2/3. 18 goes into both of those. It's 2/3. And that's a represent, so the volume of this sphere is 2/3 the volume of the cylinder. So if the volume of the sphere equals 2/3 the volume of the cylinder, then that's going to equal to 2/3 the area of the base times the height. So that equals to 2/3 pi r squared times the height is, what's the height of the cylinder?
2r.
2r. And then I simplify that, and that's going to be 4/3 pi r cubed. That's how we come up with the formula. Find the radius of the sphere for which the surface area and volume are the same number. How could we do this? The radius of the sphere. Yes, Shatish.
We said 4/3 pi r cubed equals, it has to equal 2/3 pi r squared.
No, not 2/3.
Wait, I meant pi r squared each.
Nope. Jordan?
4 pi r squared.
Yeah. You set the area formula equal to the volume formula. So it would be 4 pi r squared equals 4/3 pi r cubed. So then I simplify, so I'm going to multiply both sides by 3/4. 3/4 equals 4 pi r squared. It's equal to 3/4 times 4/3 pi r cubed. And then we simplify, so that's going to be the r squared and the pi's cancel. R squared makes this just r, and the 3/4 cancels itself out, so and the 4 and the 3 cancel, so we're left with 3 equals r. So the radius would equal to 3. All right, any questions there? Shatish?
Shouldn't we test it out to make sure that would work if you plug it into the original formulas?
Well, assuming we did the algebra correct, we don't need to test it. But you could pick numbers if you wanted to and plug them in and see if it worked. You could check it. Dimensional analysis to convert units of volume. What would 1 yard cubed be in feet? Good, 27. It's 3 times 3 times 3. It's 27 feet cubed. 1 foot cubed in inches would be 12 times 12 times 12, which is 1,728.
Yep, it works out.
Okay. And then 1 kilometer cubed, how many meters is that? It's 1,000 times 1,000 times 1,000. So that's going to equal to,
1 billion?
1 billion meters cubed. So when you're converting, make sure you multiply your conversion factor. You make sure you cube it. So as it says, calculate the volume of dirt that must be removed from a 200-foot long trench with its cross-section dimensions as shown in the figure. I'll draw the figure up there. The volume of do the volume in cubic inches first, then convert to cubic yards. So our shape is .50 inches tall, 54. Oh, this is a right angle, and it's 54 inches wide on the bottom. This is 66 inches, and then it goes back 200 feet, right? So the volume is going to equal to, of a prism, what do we use for volume?
1 for a prism.
Volume of a prism, what do you use?
Area of the base times height.
Yeah, big A times H. So then then big A is going to be equal to 1/2 base 1 plus base 2 times little h, and then times the overall height. And we plug in our numbers. So that's going to be 1/2 of 66 plus 54 times 60, or not 60, 50, times 50 times, we have to convert 200 feet to inches, so I take 200 times 12, that's 2,400 inches, times 2,400, and that's going to give me 7,200,000 inches cubed. Alright, now we have to convert the 7,200,000 inches cubed to yards squared. So to do that, we take 7,200,000 inches cubed and we multiply it times, we got to convert the inches to feet. So 1 foot squared, how many inches are in 1 foot squared? 1,728 inches cubed times, then we got to convert yards to yards cubed from feet cubed. How many square cubed feet in a cubed yard? 27. And that's going to, I multiply all that out, and I'm going to get 154.32 yards cubed.